We are taking multiple choice questions on microprocessor. What is microprocessor? Micro means small and processor means which takes certain input, processes it and output certain thing. For example, 2 and 3 is coming. The microprocessor, if you want to add, it will give you 5. If you want to subtract, it has to give you -1. So whenever you see a computer now, the cabinet inside that there is a processor. So here the answer, all the answers has PLD. This word means programmable logical or logic device. So the answer here is a microprocessor. This is a multi-purpose PLD that accepts the binary data as the input. It processes the data, whichever instruction is instructing what to do, and then it outputs. Which of the following is correct about 8086 microprocessor? Now you see the picture, you can see 8086 also, and there is an year also, 1978. Along with this, Intel is also written. So this is the Intel 8086. This one is Intel's first x86, that is first x86 processor. And Intel launched the most powerful processor in terms of advanced architecture, that is this 8086 processor in 1978. So it has a larger memory addressing capability and also a powerful instruction set. So the answer here is Intel's first x86 processor. Which of the following is a type of microprocessor? So all of these types, CISC, RISC, EPIC, all are the type of microprocessor. So CISC is complex instruction set computer, RISC is a reduced instruction set computer, EPIC is explicitly parallel instruction computing. The microprocessor of a computer can operate on any information if it is present in dash only. So if you see the formation, there will be a processor in the central processing unit, then it interacts with cache memory, that interacts with RAM, and finally the secondary storage, which we call as SSD or the hard drive. So the CPU will only access the data from the random access memory, which is the volatile memory. The storage, which is the SSD, etc., they are the main storage. So they are non-volatile. So the answer, see, first of all, the other options. Program counter is a register, 16-bit register, which you see here. Flag, they just give you whatever arithmetic logical things are happening, so it gives you the indication what has happened. So secondary memory, as I said, it is not interacting CPU. Main memory is the key. So if the information has to be in the primary storage, otherwise if it is in the secondary storage, the processor won't take it from there. Which of the following technology was used by Intel to design its first 8-bit microprocessor? So the answer here is the first one, actually, because it is being asked that Intel to design its first 8-bit microprocessor, and that is called PMOS, P-channel metal oxide semiconductor. NMOS, PMOS, CMOS, all these are the technology. So the PMOS, which is P-channel metal oxide semiconductor, this technology was used for designing the processor because this technology was slow but quite simple at that time. And then the technology advanced and there were other things which came. Which of the following addressing method does the instruction move A, B represent? See, first of all, there are different kind of addressing method. Addressing method is nothing but where the data will be, whether it is available right there or in the register or in the memory. So this is the addressing mode. So the answer here is register indirect addressing mode. In the register indirect addressing mode, the address of the operand, that is on which the opcode is going to operate is stored in the register. And since the instruction specifies that the register used to refer to the address is accessed indirectly, that is why it represents the register indirect addressing mode. So we have register indirect addressing mode also and direct addressing mode also, which you see as the option B. So let us just see here. This is the opcode. This is the indirect addressing mode. That is, you won't have the data right. You will have the address of the data. What is the word length of an 8-bit microprocessor? So this is the first is the answer. How does it come? See, the word length of 8-bit, 8-bit is minimum, so 8-bit is the minimum one. How far it can go? So at a time, 8-bit CPU can process 8-bit of data. But depending upon the type of microcomputer, the range, word length range from where? 4 to 6, this 8 to 64. That is 2 to the power 8, 8 to 64. In 8-bit microprocessor, how many opcodes are present? Opcodes, that is, this is coming from the instruction. Instruction is coming from the instruction set. Every microprocessor has certain instruction set. Okay. So in 8-bit microprocessor, we have how many? See, 8 means 2 to the power 8 is the highest limit. But here we have 256. Every operation has two parts. An opcode part and the second part, which is the operand part. For example, move A, B. So first part is the instruction and second part is the data. In an 8-bit microprocessor, maximum 2 raise 8, which is 256 opcodes, these are possible. But it consists only of 246 opcodes. Which of the following is not true about the address bus? Which is not true about the address bus? So let me show you here. See, 21 to 28, one by one we are taking. 21, 28, it seems to be true. We'll talk about that. This second option is, it is a bidirectional bus. This is absolutely wrong because address bus is just unidirectional. Address bus, data bus though is bidirectional. It is bidirectional. And this 21 to 28, it is true. And this address bus is 16-bit in length. This is also true. From AD0 till AD15, this is address bus. So it is 16 bits in length. The lower address bus lines AD0s to AD7, this is called the line number. So data bus in the microprocessor is bidirectional, but the address bus is unidirectional. AD0 to AD7 are the address lines that can be used for both address bus and the data bus together because they have the ALE, and on the latch will tell you address bus or data bus which is going to be used. So the answer is B here. Which of the following is true about microprocessors? So microprocessor is an integrated circuit that contains all the function of the central processing unit of a computer. So the answer here is true about. The answer is C. It contains the ALU, arithmetic logical unit, CU, that is the control unit, and the registers. So the microprocessor don't have memory and interfacing circuit. You see here you have all the other aspects. They follow the Princeton architecture and they contain the arithmetic logical unit, which we call it as ALU, which you see also in the architecture of 8085 microprocessor. The control unit also down below, and also the registers BCD, HL, WZ, all is there. Which of the following is the correct sequence of operations in a microprocessor? So whenever there is an instruction contains of the, for example, we have LDA, certain operation. So there will be certain fetching and there will be some storage and reading and writing will be done. So what is the process? What means correct sequence? So fetch will be done, decoding will be done, then the execution and the storage. This is the whole instruction cycle which is being followed for any kind of instruction. So what is the correct sequence of operation? We have, see, first of all, because first thing is opcode, then operand comes. So opcode fetch will be done. then the memory read and memory write will be done, and then the input output read and input output write will be done. So this is the correct sequence of operation in a microprocessor. The dash directive instructs the assembler to begin memory allocation for a segment block code from the stated address. So in order to begin this memory allocation, ORG will do. ORG, you can say a short form of origin. The answer is C here. So ORG, it means origin. ORG is used for specific addressing in microprocessor and the microcontroller programming. Let us take an example. The location counter is actually initialized to 00H. For example, if ORG 0000H is there, this means we want to start our program from this address 0000H. So whenever the ORG we write, the assembler starts the location counter to keep track of the module's allocated or allotted address as specified in the directive, which is ORG. ORG is all about starting the address, origin. Which of the following is not a microprocessor? Now, see, the answer will create a more question here, because first of all, P1C1, this is a microcontroller. It is a 8-bit microcontroller. But Z8000, Motorola 6809, Zilog Z8, these are all the microprocessor. While the last one is the microcontroller. So what is the difference between microprocessor and microcontroller? Whenever you see a computer system, microprocessor, these are widely used in the computer system, laptops, etc. Microcontroller, they are widely used in the embedded system, like your washing machine, like your microwave oven. Microcontroller. So this microprocessor, it has only CPU in it. Microcontroller, it has CPU, fixed amount of RAM, ROM, and there are other peripherals also embedded in it. So random access memory, ROM is there. In microprocessor, we have to connect all the components externally. So externally means there will be peripheral device, all the input, output, address, data. This is going to happen. While in microcontroller, you see all the components are internally connected in microcontroller. So the circuit is quite compact. The microprocessor, because of this reason, it consumes more power. And microcontroller, because of this reason, because everything is in one place, it consumes less power than the microprocessor. Microprocessor, it has very less internal register storage. For example, 8085, we have just B, C, D, E, H, L. So it has to rely on external storage. So all the memory operations are carried out using memory-based external commands, which results in high processing time. Because microcontroller has everything embedded, it has many registers also. So processing time is less. So this is the difference between a microprocessor and microcontroller. So these A, B, C options are microprocessor. The last one is the microcontroller. I hope you got the difference between these two. Which of the following is not a property of trap interrupt in microprocessor? Trap is an interrupt. Say when the system is working and you suddenly take out your pen drive, what will happen? How do the microprocessor will know? So there are certain devices which are connected, peripherals which are connected. So the microprocessor need to know. So this comes through various interrupts, and one of the interrupt is trap. The trap has the highest priority. First of all, it is non-maskable. I'll tell you just now that the answer of this question is which is the following is not a property. So C is it uses edge triggered signal. Let me tell you first that the trap is a non-maskable interrupt. That is, whatever is coming, when trap will come, microprocessor has to deal with it. That is, it cannot be disabled or ignored by the microprocessor. Others, RST 7.5 till INTR, they are maskable. They can be disabled, they can be ignored. And this trap is a vectored interrupt, highest priority, non-maskable. But the third one, why it is wrong? Because the trap interrupt uses both level and edge triggered clock, because it is of highest priority among all these interrupts which I showed you. Which of the following is a property of RST 7.5 interrupt? Okay, so these are the interrupts. And when we talk about processor, we have the software interrupts and the hardware interrupts. The trap has the highest priority. It is a non-maskable interrupt. That is, when it comes, the processor has to handle it. And they have different signals, leveled signals, right, triggered signals. Vector address is also there. So which of the following is a property of RST 7.5? This is being asked here. Now the answer here is D. It's vector. It is a vectored address, and the address is 0034. So all these options, that is, first of all, RST 7.5 is a maskable interrupt. That means it can be delayed, it can be disabled or ignored. The priority is second here. If you see, this is the highest priority trap. Then we have RST 7.5. It has the second priority, not the third priority. And its vector address is 0034. That is absolutely true. It uses the level triggered signal. Actually, it uses only the edge triggered signal. Only edge triggered signal. The trap uses both of them. Which of the following flag is used to mask INTR interrupt? Okay. So when we talk about the other aspect, when we talk about different flags, trap has the highest probability, say priority, sorry. And then we have INTR, the lowest one. We talk about flag when there are certain operations on the ALU. But whenever we talk about the interrupt, there is an interrupt flag, which is not here, which you see here. I just showed you because this is the basic flag we talked about. But we are talking about entirely different kind of flag, interrupt flag. If the interrupt flag IF is 1, if this is set that it is equal to 1, the microprocessor will serve any interrupt. The processor ignores the service if the interrupt flag IF is set to 0. If it is equal to 0, then it is reset. Which of the following is a special purpose register of microprocessor? Okay. In any microprocessor, the instruction register, the accumulator and temporary register, these are general purpose register. Because accumulator, whatever is happening will happen in accumulator and also saved in accumulator by default. This is accumulator. Okay. Now the answer here is instruction register, because the program counter is what? Program counter is different. Program counter holds the address of the next instruction which has to be executed. For example, if this is these are the whole instruction which are in assembly language. So if we are working on this, PC will hold the address of the next one. Okay. This is 16-bit. Which of the following circuit is used as a special signal to demultiplex the address bus and data bus? So let me tell you whole scenario first. From the whole 16-bit address or the 16-bit wire is from AD0 to AD15. This whole is the address bus. Okay. But the one part, AD0 lower part, AD0 to AD7, this also works as the data bus. Okay. Now, who is going to decide that when this whole wire will be used, all the 16-bit will be used, that is, it will be used as the address bus, or the first 8-bit will be used, that is, only it will be used as the data bus? For that, we have the address latch enable. So address latch enable is a positive pulse, and it is generated whenever the microprocessor starts an operation to latch the lower order address lines AD7 to AD0, or you can call it as AD0 to AD7. Because ALE, address latch enable, it indicates that the bits on AD0 to AD7 are the address bits. Okay. Then this signal is used to latch the lower address from the multiplex bus and generate a separate set of 8 address lines, which is the A0 to A7. This is just like a latch which you use. Sometimes it will be used, this whole will be used as a data bus. Sometimes it will be used as the address bus depending upon the situation. Okay. How many flip-flops are there in flag register of 8085 microprocessor? So we have the 8-bit register for depicting or showing the flags. So how many flip-flops are there in flag register? See, one flip-flop will have 1 bit. When we take 8 flip-flop, we start calling it as a register. So all of these 8-bit are not used because these are flag register. The B1, B3 and B5 is not used. So if 3 is not used from 8-bit, how many are there? 5 is there. So there are 5 flags or flip-flops in a flag register in 8085 microprocessor that shows the status for the arithmetical logical operation. They are mainly affected by the content of, mainly I'm saying, not always, but mainly by the accumulator. Which of the following flag condition is used for BCD arithmetic operations in microprocessor? BCD is a binary coded decimal, and BCD, see, first of all, the answer here is auxiliary carry flag. But in order to understand the answer of the question, we need to understand auxiliary carry flag. For example, these are all the options. Parity flag will be 1, even number of parity, even number of ones. So among all these 5 flag conditions in the microprocessor, the auxiliary carry flag we are talking about, the auxiliary carry flag is used internally for the binary coded decimal BCD arithmetic operation. And based on this auxiliary flag, the instruction set doesn't contain the conditional jump operation. What does it mean? That we have 8 bits. So the smaller part, that is the nibble. So this auxiliary carry flag is set when there is a carry out of a lower nibble 4 part or lower 4 bits of the operation. So I'm not talking about whole 8 then the carry. I'm talking about 4 that carries upon to the 5th one. That sets the auxiliary carry flag. Whenever a non-maskable interrupt occurs in 8085 microprocessor, which of the following data line contains the data? So we'll talk about this in the later discussion. Thank you so much. Take care.